Dear students, in this video we are going to talk about the bipartite graphs. Okay, very important point in the graph theory, that is bipartite graph. So first of all, we will go with the standard definition. A simple graph. So you already know the simple graph. Simple graph has at least a single edge between two vertices. Okay, graph G is called as bipartite if its vertex set, if there are vertices in vertex set V. So if we partition those vertex set into two disjoint sets V1 and V2 such that every edge in the graph connects a vertex in V1 and a vertex in V2. Okay, so if you get any edge of the graph, if you take example of any edge in the graph, this graph, the edge will be connecting vertex from V1 set and vertex from V2 set. Okay, so every edge is connecting a vertex in V1 and vertex in V2. So we call this pair V1 V2 bipartition of the vertex set V in graph G. Okay, so here one more point you should remember, that there is no edge that will connect two vertices in same vertex set V1 or V2. Okay, so take the example of this graph. So this is having 6 vertices V1 to V6, and this has been partitioned into two sets. So this is first set and this is second set. Okay, so we'll take example of any edge of this graph. Suppose if you number these edges 1, 2, 3, 4, 5 and 6. So take any of these 6 edges. Let's say take the edge number 5. Okay, so this is connecting a vertex in set V1 or this first set to vertex in second set. Okay, so if you take example of any edge, it will be connecting a vertex in first set and vertex in second set. Such graph is called as partitioning of the graph. Okay, and such graph is called as bipartition graph. Bi means there are two sets, so that's why it is a bipartition graph. So in V1 set you will find node 1, 3, 5, and in V2 node 2, 4, 6. Now to find this, I will tell you one trick that how to find, because if suppose you are having, let's say, such graph. Now this was a simple graph where is this graph where you could have got easily that these are the two sets, but here you will need to apply some logic. Now what is this logic? You will apply coloring method. Okay, coloring method you can apply to this graph to check if it is bipartition or not. Okay, so bipartition graph, bipartitioning, right? Now see what you have to do. You have to apply the coloring method. Okay, so what is the coloring method? It says, so neighbor means the node which is connected with an edge with another node, that is a neighbor. So neighboring node should not have the same color. Suppose if you start giving the colors, so suppose I am giving here blue color. Wait, suppose this A, I am giving vertex A as a red color. Okay, so all the neighbors of this vertex A should not have the same color. It is having two different colors. So if you are able to give different color to the neighbors of this vertex A, so which are the neighbors? Node B, node C and node E. So you have to give your blue color for node C because it is a connected neighbor. This E will also be having blue color and B will also be having blue color. Okay, why we have colored them? Because the neighbor should not have the same color. Now check further. Okay, now take the example of next vertex. Take the example of vertex B. So vertex B is having blue color, so all the neighbors of vertex B should have red color. So A is already having red color. Now F is the neighbor of B, so F should have red color. Now again next neighbor is D, so D is a neighbor of B and B is blue, so D should have red color, right? So all the neighbors of B we have traced. Okay, so this D is having a red color. So we have traced all these vertices, all these neighbors of B. Okay. Next, we will take the example of this C. Vertex C is having blue color, so all the neighbors of vertex C should be having red color. So G is the neighbor of C, so it should have red color, right? So G is red, right? Now only a node that is left, that is H. Okay, so H should have blue color because all the neighbors of H is having red color. Okay, so we will here give here blue color. So H will be having a blue color. So now you will find we have traced all the vertices of this graph. Now combine the similar color vertices. Okay, so combine all blue colored. So blue colored are C, then E, H and B. So C, E, H and B. So these are the blue colored vertices. In second set we are having red color vertices, that is A, then G, then F and D. So A, G, F, D, these are red colored vertices. So these are the two sets. So these are the two disjoint sets of this graph. You will find each of these vertex in blue colored set is connected to red colored vertex. So if you take the example of this A, G, F, D, so if you find H from G, so this will be having connection to the all blue colored vertex. So this will be, if there is an edge, this edge will be between these two sets. So that is called as bipartition graph. Okay, so this is complete bipartition graph where you will find every edge connected to every other edge. Okay, so here also you can check if it is bipartition or not. So start giving colors. So I will do the same color now. Let's say we will use same thing. So suppose you give here red color to this A. So A is having red. So C should have blue and B should have blue. Okay, you already know these things. Now let's say the example of B. B is blue, so D should have red and this F should have red. Now F and C are neighbors, so they are having different colors, so it's okay. Now F is red, D is red, so E is blue. Okay, but here see, this should not be happening because C is a blue and E is a blue, so they are neighbors. So this graph is not a bipartite graph. This is not bipartite graph. Not bipartite because the condition is not satisfied. We cannot divide this graph into two sets. Now remember that we have to use only two colors here, red and blue, or any other, but only two colors you have to use because this is bipartite, so you should have two disjoint sets. Okay, next is complete bipartite graph. In complete bipartite graph you will find every node is connected to every other node in the set, another set. So suppose this is first set, this is another set. You will find every node in set 1 is connected to every other node in set 2. So every vertex of first set is connected to every other vertex of second set. So it is called as complete bipartite graph. So here also you will find this is a complete bipartite graph. Remaining points, remaining topics we will see in the next lecture. Thank you all.